This is a series of videos that I am writing to help that I'm producing to help some family members learn basic statistics and R coding simultaneously. So that statistics can be learned using practical, real-life analytical exercises. This way, people can learn the concepts while also learning how to execute them in real-life data analysis situations. So traditionally, statistics is taught conceptually first, and you learn the math behind the methods for a couple of years. And then after those couple of years, you start developing actual coding skills. Now, there's really no reason for this staggered approach, and I think it often hinders students from developing their skills as hands-on analysts. So these instructionals are meant to accompany the Kahn Academy lectures on YouTube. Now, it's worth noting at the outset that I am in no way officially associated with Kahn Academy in any way. I just think they are great resources for learning the basics of statistics, and I hope that these movies the series of YouTube clips will help people learn the basics of R coding at the same time. So first, a note on the software we're using. We are using R, and specifically R Studio up here. R is quickly becoming the primary statistical software for most fields. Its main benefit is that it's free. Most of the proprietary statistical softwares such as SPSS, SAS, Stata can cost quite a bit of money. Some of the licenses run into the thousands of dollars. Whereas with R, in the spirit of Kahn Academy, R helps people kind of learn statistics who don't have the resources to spend on $1,000 licenses. However, just because it's free does not make it any less powerful. Matter of fact, R is more sophisticated than most of the proprietary programs. It's much more cutting edge. When a statistician comes up with a new approach, a new technique, method, they oftentimes will turn around and write up an R file and then submit it so that other people can use that package in their own analyses. So R is probably about 10 to 20 years ahead of some of these other proprietary programs. Third, R is also very customizable. So with proprietary programs, you're kind of stuck doing what they want you to do, the options that they give you, whereas with R, you can pretty much customize it to whatever extent you want and do whatever you want. So for these reasons, like I said, R is quickly becoming the program of choice. It's sometimes it's not as easy to learn as other coding programs. If you do have a coding background, this will be much easier, but frankly, the learning curve in learning R is not as steep as some people suggest. So we'll begin with describing R a little bit. R is an object-oriented program, which is a fancy way of saying that whatever you are working with, whether it's a string of numbers, a spreadsheet, a formula, or a table of statistics, R treats it as an object. So objects are stored over here on the right. So like many programs, you can create objects that are assigned numbers. And so we'll make one of those as our very first object, just as an example. So let's create an object called A, and let's assign it the value of 1. So our object of A is simply the number 2. Now we can highlight this and we can run the program, or we can come down here and directly enter it in. We'll do B and directly enter it in here. And it does the same thing. So now we have two objects, A and B. Also, if you prefer, you can do the equal sign instead of this caret in horizontal line. So let's make a C equals 5. Highlight that, run it. So we have this other object. So again, whether you use the equal sign or whether you use the caret and the horizontal sign, it makes no difference. It's really just a matter of preference. So for the first Kahn Academy section that we'll start with is the categorical data analysis, categorical data displays. Now again, if you go through these movies, you should understand the statistics underlying what we'll be doing here. So we're going to start with simply creating different categorical data displays. First off, we'll create a bar plot. So to create a bar plot, we're going to use the famous MT-CARS dataset. Now, the MT-CARS dataset is a built-in dataset, which means that it comes native with the program. and you don't have to, it doesn't come as an object. So, or it is an object, but it's not up here in the working environment. So you can do things with it. You don't have to load it like you do with other data. Speaking of which, we're not going to go over loading your own data here. There are a lot of tutorials, a lot of information on how to do that elsewhere on the web. So if you are interested in learning how to load your own data, simply Google how to load data into R or something like that, and you will get more than enough information on how to do that. So, but you don't have to do that with empty cars because it comes with the data set. However, we want to see it as an object, so we are going to create another object. Let's call it the copy of empty cars. And so it's going to be a copy of the empty cars data set. We're going to assign empty cars to it. Run. And then this gives us the copy of the empty cars data set that has 32 observations across 11 variables. And you can click on it directly, and this will show up as a spreadsheet. So as you can see, this data set is a series of cars, and they're different specs, they're different mechanical characteristics. So we have miles per gallon, how many cylinders, displacement, horsepower, weight, etc. So if we want to do a bar plot, we use the bar plot command. You will find this pattern with a lot of R commands. The developers try to make it as simple as possible. So if you have a particular method or technique, there's a good chance that the name of the command follows the name of the technique. Oh, one other thing I forgot to mention is when you are assigning objects or names or anything like that in R, you can't use spaces. So if we try to do this, we get an error message. It doesn't work. It's an unexpected symbol, and that unexpected symbol is an empty space. You cannot do that. So the traditional way of working around that is you add an underscore in between numbers that you want to separate. So we're going to create our first bar plot. Now when you do commands in R, you use parentheses. So you use the command, and then you put in parentheses, and then inside the parentheses you put in the object that you want the command to work on. So we want to create a bar plot of, let's look at the different variables. Let's say the number of cylinders that we have. So we simply go bar plot, copy, empty cars, or empty cars, either way, because they're both the exact same. And then if you want to refer to the variable, you put a $, and then you type in the name of the variable, or you select it up here, which you can do in RStudio. Type it in, cylinders. So usually the graphics come up over here on the right side. And as you can see here, this is not a very interesting graph. It has 32 bars, which is one for each car, in a sequential order showing how many gears there are. Now traditionally when we want a bar plot, we want to see how many of each kind of something there are, right? So to do this here, we would have to run a bar plot on what's called a frequency table. Now to make a frequency table, we would basically have to make a data set, another data set from the original data set. So you can make a frequency table using the table command. Now we'll talk about this more later, but the table command is useful if you want to quickly look at how many cases fit in each category or level of a variable in your data. For example, if you have a spreadsheet showing survey respondents and their marital status, income, education, etc., and you wanted to look specifically at marital status to see how many are married, how many are divorced, how many have never been married, etc., then you can simply use the table command. In this case, we can see how many cars have each number of gears. So we say table, empty cars, or we'll do copy empty cars. Again, it doesn't really matter because they're identical. And then we'll do, did we do cylinders or gears? Let's do gears this time, but we'll do cylinders. So as we can see here, there are 11 cars with 4 cylinders, 7 cars with 6 cylinders, 14 cars with 8 cylinders. Now how do we want to take this and we want to convey it in a bar plot like this. So what we have to do is we have to create an object out of this table. So instead of typing table and then just having this output here, we have to assign it to an object. So let's say, let's create an object called cylinder table, sil table, and assigned it to this table up here. So that creates this new object up here, which if we type the name of that object, it will give us the exact same results as the printout up here. But now that we have an object, the advantage is that we can make a bar plot out of it. So bar plot out of cylinder table. There we go. Now this looks more along the lines of what we'd expect to see in a bar plot, as discussed in the Khan Academy lecture. Now this bar plot is kind of boring, and it's kind of confusing. We don't quite know what 4, 6, or 8 mean. We don't know what these numbers mean. I mean, we do because we've talked about it, but if you were to just show this to somebody, they'd really have no idea. So that you can spruce it up a bit, and it's really easy to do that in R. So we are going to do that. So you put in the name of the object, and then if you want to put a subcommand that includes additional information, you simply put a comma, then you put the name of the subcommand. So for example, the subcommand to put a title is simply main. Let's do figure 1 cylinders by car number. So that's the name of our graph here, and then it adds a title. You can add more things. You can put an X label access, which is the xlab subcommand. That is cylinder number. You can add that, and then we get this. Finally, we can add a y-axis. Now, it's worth noting at this juncture that you can go onto a second line. Not that way. Let me do this. There we go. You can go onto a second line. Actually, we'll just do it up here. It's a lot easier. So we have this command here, and then if we wanted to add second line down here, we can just keep on putting more commands down here. So it's a y label equals the number of cars. Because the important thing is, it's not the line that it's on, it's that they are inside the parentheses. So we can, this is very useful if you have a very long command and it goes all the way out here, and it could go all the way out here and you have to scroll all the way over to see the entire command, or you can stack it vertically instead, which is what we've done here. And this should add the y-axis here, number of cars. So finally, R allows you to use parentheses within parentheses, basically allowing you to execute a series of sequential commands on a single line. So for example, here we've created the cylinder table object. Well, we created the cylinder table object previously, and then we were able to invoke it here. But because you can use multiple parentheses within parentheses, you can create the cylinder table object within the same command that the bar plot operates on. So for example, we can create a bar plot not of the object itself, but of the table of our copy empty cars. We can add this material. There you go. So it creates the exact same graph. You couldn't notice it here. Let's change it up so you can see the difference. Let's say number of cars, capitalize the C. So we'll run this now, and then this will change to a capital C. So as you can see, we didn't actually put the name of the object in here. We said, okay, we want you to basically create an object of the table, a frequency table here, and then after that's created, we want bar plot to operate on that. So this comes this becomes very useful if you want to parsimoniously execute a certain command and you don't want to have lots of different lines of code. So you can just include it in one clean command, and it can incorporate all of the different equations or aspects of the command that you want it to without doing it sequentially. So these are some of the basics for how to get started with R. Hope you enjoyed it, and thanks for listening.